So our second concentration unit is molarity. And I noticed again that I was I got the slides off the PowerPoint on my iPad, and I think it took away a few things. So let me fix it. So molarity, if you look at this equation and compare it to percent concentration, first of all, there's only one way for molarity, okay? And so we don't have several ways. The second thing is that they use different units. So the units in molarity, the solute is going to be in moles, and the solution is going to be in liters. Okay, so previously in percent concentration, we were comparing weight or mass in grams and volume in milliliters. So you really have to remember which units go with which which concentration unit. And at that point, too, let me just mention, in our class, we're really just looking at percent concentration, which is used a lot in commercial products, and then molarity, which is really one of the big concentration units used in chemistry lab. So we're looking at those two, but those are not the only two types of concentration units. In your area of study, you may find or learn about other concentration units. So we're just picking two of them to look at. Back to molarity, I want us to be sure we're thinking about the units that are used, because that will be important. The other thing I want to point out is the abbreviation for molarity is just a capital M. And so anytime you see capital M, you can associate that with a concentration unit that is comparing moles to liters. MOL is moles. So don't get confused if you see MOL, that's moles, and a capital M is molarity. So I have three problems for us to do, just with a variety of units and how we might approach it, calculating the molarity or calculating a different part of that equation. So let's give it a try. So this says calculate the molarity of an aqueous solution that has 2 moles of sodium chloride and 250 milliliters of our solution. So I'm just going to write the equation up here. Molarity, which is a capital M, equals moles of solute divided by liters of solution. Okay. No times 100, it's not a percent. So I look carefully and I already have the moles. So I can plug in 2 right there. But then I come down to the volume, and this is 250 milliliters. So because it's milliliters, I cannot use it. So I must convert milliliters to liters. The relationship is there's 1,000 milliliters in 1 liter. And to convert milliliters to liters, you divide by 1,000. Or you can simply think of it as moving the decimal 3 places to the left. And I suppose there's only 2 significant figures there because the 0 doesn't have a decimal after it. All right, so 250 milliliters is 0.25 liters. So now, knowing that, I can take 0.25 and plug it here. So my molarity is going to equal 2 moles on the top over 0.25 liters on the bottom. What is that? 2 divided by 0.25, 8. Oh yeah, 8, that makes sense. 8, and it all comes out as 8, and I want 2 significant figures, so I have to add a 0.0. Now, if you look, the unit here is moles over liters. Okay, that is molarity. So this is just capital M. And if you think to lab, these are the kind of labels we've seen. We haven't really been working with concentration, but like it might say, get 3M HCl. Well, that 3M was the concentration of the HCl. So this solution would have a label that said 8.0 M NaCl. So that is the molarity of the described solution. So let's try another one. Okay, this one says calculate the molarity of acetic acid in vinegar that contains 5 grams of acetic acid in 100 milliliters of solution. All right. So we know that molarity is the moles of the solute divided by the liters of the solution. Okay, so I have a problem here because I have grams. So I know first I need to go grams to moles, which we learned in chapter 5. Whoops, I don't know, my iPad is somehow being unhappy with me. It keeps making little lines. And then we also know it's in liters, and I see here they didn't give me liters, they gave me milliliters. So I'm also going to have to convert milliliters to liters. So I have to do both before I even just plug it in. So if you remember from chapter 5, if you take the grams that are given, which is 5 grams, and you divide it by the molar mass, which we were given the molar mass in this equation. A molar mass is calculated by adding up all the elements in the formula. That gives me the number of moles. So grams, 5, divided by the molar mass, 60.05. And I get 0.0833 moles. So that's how many moles of acetic acid I have. And then milliliters to liters, we did this in the previous problem. There is a decimal there. You divide the milliliters by 1,000, or you can think of that as moving the decimal to 3 places to the left. And we get 0.100 liters. And I maintained the 2 zeros because in what's given up here, there is a decimal at the end. Okay, that doesn't solve the problem. That just gets us into the correct units. So now looking at it, I have moles here. That can be plugged into the top. And then I have liters here that can be plugged into the bottom. So the molarity is going to equal 0.0833 moles. And I'm going to divide that by 0.100 liters. And remember, I'll say it, there's no times 100, right? This is not a percent. And we get 0.833 molarity. That's moles per liter acetic acid, which is what vinegar is. It's a concentration of acetic acid. So the capital M is what moles per liter is. That's what this capital M is. So we just write capital M. So this is our answer. So my advice in this problem is to look at the units when you're doing molarity. If they give you moles and liters, you just get to plug it in. But if they give you grams, you'll have to use the molar mass to convert to moles. Or if you're given milliliters, you'll have to use the relationship between milliliters and liters to convert into liters. Then you can plug in. So we don't always have to do what I just did here, but you got to look at the units and see if you need to do it. So I have one more example in this particular section. And it says, how many milliliters of a 0.15 capital M molar glucose solution contains 0.20 moles of glucose? Okay. So this is not asking me to find the molarity, but it is giving me a molarity. So when they give you a molarity, you can think to yourself, I know an equation for molarity that might help me. So that's the equation for molarity. Now, they gave me the molarity. So they gave me this number right here. Okay, so I know that number. And then let's see, what else did they give me? They gave me the number of moles. So I also know this top number. And what they're asking me to solve for is the amount of solution. Now, if you read carefully, though, they asked me in milliliters, and when I first solve for it, it's going to be in liters. So once I get the liters, I'll have to change it into milliliters. So let's give it a try. First, let's get the liters. So I'm going to plug in. I have 1.5 m. And if you want to use the units, you can. So capital M is moles over liters is what it is. And I know that's in 0.020 moles. And then I'm trying to find the volume. So anytime that what you're looking for is in the denominator, you have to multiply it over to the other side before you do any more rearranging. So I'm going to multiply it over, and I'm going to have volume times 1.5 molar, which is moles per liter, equals 0.020 moles. So I just multiplied volume to the other side. And now to get the volume by itself, I'm going to divide 1.5 to the right-hand side. So volume equals 0.020 moles over 1.5 mole per liter. The moles end up canceling, and there's our units of liters. I do have in our Canvas shell ways that you can use concentration units as a conversion factor. If you want to look at that, you can. It's not required. You can do algebra, what I'm doing here. At one point, the book really pushed that, and so I have some videos with it. Let's see, two significant figures, so 0.013 liters. Okay, it is. I get lots of threes, but I'm rounding it to two significant figures. And then I want it in milliliters, so I'm going to multiply by 1,000, which means I'm going to move my decimal 3 places to the right, and so I get 13 milliliters. So rereading the problem, if I had a glucose solution of a 1.5 molar concentration, 13 milliliters of that solution would contain 0.02 moles of glucose. So just remember, in all concentration problems, you can solve for concentration, or if they give you concentration and one other thing, you can either solve for the solute or for the solution.